The final part of the chapter is epistemic practices and cognition. This is looking at the way science is done in the real world, which we call the nature of science. When you were in school, you probably learned science through the scientific method, where you have a hypothesis, then you do some tests to see if that hypothesis was correct, and then you go back and maybe tweak your hypothesis and do it all over again. We're kind of shifting away from that sort of method because that's not really how science is done in the real world. Now we are using this claim evidence reasoning, or CER, way of doing things, where we ask a question, we make a claim, which would be the answer to that question. So an example would be, why is the sky blue? Your claim could be, the sky is blue because the light is coming through the atmosphere and scattering scattering the blue wavelengths of light. Now we need to find evidence to back that up, and then give our reasoning that the evidence backs up that claim that we've made. And if the evidence and reasoning don't back up that claim that we've made, then we need to go back and rework our claim. This is more representative of what scientists actually do in the real world. The NGSS science and engineering goals do a great job at encouraging this nature of science. So it starts with asking questions, defining problems, then make a model to figure out how we could maybe see that problem in a different way. Then we investigate, we analyze data, maybe you use some math to help you out, but then you're going to construct an explanation. That's where your CER comes in, and you show it to your peers, argue it to see if they also agree with that, and then communicate whether it's true or whether it's not.